Hi everyone, welcome back. In this video, I'm going to talk about Numpy, especially about matrix and vector operation. So the learning objects of this tutorial is to learn the basic operation in one-dimensional as well as multi-dimensional arrays. We also learn how to do the basic calculation with array, such as how to do the average over the different dimensions. Alright, the first thing that we need to do is to load the library. We use the command import numpy as np, as you can see here. In the second section, we are going to learn the basic operation for array in numpy. Here I have two different arrays, x and y. When we print these arrays, we will see that it is 2 by 2 matrix because it has 2 rows and 2 columns. So we can do some basic operations such as addition, as you can see here. The number 6 here is the output of the first index, the first value in the x array, plus the first value in the y arrays. So 1 plus 5 equals 6, as you can see in here. Similarly for other index in the array. And then we can also do the subtraction. We take the first value in the x array minus for the first value in the y arrays, then we get the value minus 4. Similarly for the other index in the array. We can also do the multiplication. So the number 5, as you can see here, corresponding to 1 times 5, and number 12 corresponding to 2 times 6 in here. We can also do the dot product by using the command numpy dot, or we can also use the symbol at, as you can see in this command. So the dot product will take the first row in the x array times for the first column in the second array. So the number 1 times 5 plus 2 times 7, and the result will be 19. Similarly, we can also do other operations such as division, as you can see in this command, and also the double the value inside a certain array. For instance, the original value for the x array is 1, 2, 3, 4. We can double these values by times 2, and then the value will become 2, 4, 6, and 8. We can also apply the power operation into the array, so that 1 to the power of 2 still 1, 2 to the power of 2 will become 4. And we can also do the division by the constant or scalar value. And in the next section, now we are going to learn another command, very powerful and useful command in Numpy, which is the concatenate. So the idea is that when you have an array, for instance, in here I have a z array, which is only two numbers, 2 and 4, and the shape of this one is 1, 2, which is 1 row and 2 column. So we can concatenate this z array to make the 2 by 2 with a similar number for each row. For instance, this is the output that you can see here. Our original z array is only 2 and 4. However, by using the numpy dot concatenate, we can have, with the axis equal 0, we can have 2 rows with a similar value at each column. So when we print the shape of this array, we will have 2 by 2 matrix. And we can also do similar things, however, not in a vertical, but we can do it horizontally. For instance, when we put the axis equal 1, so the value 1, 2 will be added at the end of the first row, so that we still have 1 row and 4 columns. Another example is that we can calculate the summation, the mean and standard deviation of an array. For instance, in this command line, I have 3 by 3 matrix, and we can calculate the sum of these arrays by using the data.sum, and it will sum up the values in this array together, so the total value will be 45. We can also do the summation along a certain axis. For instance, when we specify axis equal 0, then it will sum up the value in a certain column together. For instance, the number 12 here is the summation of 1, 4, and 7. Similarly, for 15, where we sum up 2, 5, and 8 together. We can also sum along a row. For instance, we specify the axis equal to 1. So the number 6 here corresponding to the sum of 1, 2, and 3. So this is 2D two-dimensional array, and we can do it a similar way for the multi-dimensional array, such as here I have an array 2 by 3 by 5. We can simply understand this matrix as having 2 layers, the upper layer and the lower layer. In each layer we have 3 rows and 5 columns, and to do the summation is also similar with the two-dimensional data. When we just use data.sum, and then all of the number value in these 2 layers will sum together. We can also do the summation along a certain axis. For instance, we want to do the summation along a first dimension, which is layer. This means that we take the first layer, the upper layer, and plus for our lower layer. So the resulting matrix will have the shape of 3 by 5. So it will sum the first layer in here with the lower layer, and then we still have 3 rows and 5 columns. We can also do the summation along another dimension, such as in the first dimension, where we will sum up the row. For instance, in here, we still have 2 layers. However, in each row, in each column, all of the value in that column will be summed together. So in each layer, we still have 5 columns, and however, we only have 1 row. Similarly, we can also do it for the third dimension. So we will have the shape 2 by 3, and 2 is for 2 layers, and 3 is for in each layer we still have 3 rows. However, we only have 1 column. We can also do the summation along the 2 axes, 2 dimensions, such as here I have do the summation in the first dimension and the third dimension, the second dimension, and the resulting will have the shape of 3, stand for the number of rows in here. And then we can also do something like, for instance, we have an array like this, where we have 3 by 3 matrix array, and then we can do the transport. So the row will turn to become a column, as you can see in here. In the next section, we learn about Boolean arrays and conditional expression. So here I have an one-dimensional array, a from 0 to 10. We can also print the reverse order from 11 to 1. And then we can ask whether the value in A is less than the value in B. So we specify it by using a command like this, and then where the value of A less than the value of B, the resulting message will be a true value, otherwise it will be false. We can also check if all of the value in A is less than B. Then if it is, then it will return the false, or it returns a true. However, in here we have A value also larger than B, so that's why this is return the value false. And we can ask is there any value in a less than b? So we use numpy.any, then it return the value true because there is a value in a less than b. We can also check whether the value in a is less than the value in b or not by using simply the for loop and the if condition. So in here I have if condition. Whenever the value of a is less than the value in b, then it will print a message a is less than or smaller than b. Otherwise, it will print a message a is greater or equal b, as you can see in here. Another example is that I have an X array. Those are value from -4 to 4. So if we check X, whether X is larger than 0 or not, then the resulting logical message will return the false value whenever X is smaller than 0, and also return the true value when X is larger than 0. We can also return the index or the value of the X array. And another cool thing, another very cool command in NumPy is numpy.where. It's basically like we have a condition, and then if this condition is true, it will apply some operation. Otherwise, it will also apply the condition if it is false. So the second argument here is when the condition is correct and it's true, and the third condition here is when the condition is false. For instance, so we have an X array like this, and then whenever the value in X is less than 0, so its value will to the power of 2. Otherwise, its value will to the power of 3. So we can see these negative values where x is less than 0 will to the power of 2. So that's why 3 becomes 9. And then also when we see the value of x larger than 0, for instance the number 2 here, it will to the power of 3. So that's why it becomes number 8 here. We can also use numpy.select to do the quite similar things. For instance, here is the condition where we find the x less than -1, x less than 2, or x less than or greater or equal to. Then when this condition is true, it will take the operation that we specify here, either it's for to the power of 2, 3, or 4. Another command which is also very similar to numpy where and numpy.select is the numpy choose. So in here we have along each index inside the X array we have a certain value 1, 0, 1, 2, and which is stand for the operation below here. So 0 means the first operation here, and 1 is for this operation and 2 for the last operation. So we will apply this operation to the location of each x value in X array. We can also simply use the absolute value, so it will turn the negative value to become a positive. And we can also do some conditions such as take out a certain value, for instance larger than 2. And yeah, that is all done, and thank you very much for watching.